PC, at the downlink, they have no idea what does the traffic forwarding path looks like. They have no idea. They don't know the exact topology. They just know if I want to view internet, I send a message to my gateway first. The first step is find my gateway. All right. Okay. For example, this is a switch and okay, firewall. The PC, IP address 10.1.1.1, and the gateway is 10.1.1.100. Gateway 10.1.1.254. All right. But according to this topology, in terms of physical, we know that the firewall we have two firewall, and the gateway IP address is deployed at one of the firewall. But which one, right? Firewall 1 and firewall 2. Then we use VRP. We create a VRP group at both two firewall. Okay, and this interface, the physical interface IP address 10.1.1.1. Okay, the firewall 2 interface IP 10.1.1.2. And since we create VRP group, this is a VRP group, we assume that the group number is 1. Okay, then we will generate another thing, which is called VIP, a virtual IP. And VIP is 10.1.1.254. And this is the gateway. All right. But who have the permission to control this VIP? So for the VRP group, there are two characteristics. The first is called, there are two roles. First is active. And second is backup. There are several names: active, backup, active, standby, master, slave, same. All right. And by default, the active device can control the VIP, which means this VIP 10.1.1.254 is owned by the firewall 1. And since the firewall 1 owns this VIP, the firewall 1 will send gratuitous ARP packet periodically. Gratuitous. And gratuitous ARP consists of mainly two key information. The IP address 10.1.1.254, and this is the gateway, right? And the MAC address, this is VIP, and mapping to a VMAC, virtual MAC address. And the VMAC have a specific, MAC address format 0000-5E00-010X. And this X, the value of this X is depending on the group number of VRP. And in this case, the VRP group number is 1. So now this X equals to 1. So the MAC address is 0000-5E00-0101. All right, and this is the gratuitous ARP information, and that gratuitous ARP will keep sending to the SW and send to the PC. And when the SW receives the gratuitous ARP, it will upgrade its MAC table. And the MAC table have 3 key information: port, and MAC address and VLAN. Okay, the port, for example, this is port 001, and this is port 002. It is because the gratuitous ARP is received from interface 001. So there is one MAC address entry updated. Port number 001 and corresponding MAC address, VMAC. And this one, right? This one. And VLAN, maybe 10, maybe 20, but we should care about this part. And then the gratuitous ARP also send to the PC, and PC just get the information of the gateway's MAC address. All right, and then the traffic can go this way, the left side, right? Because when PC try to access the internet, the first step is to find the gateway, because the packet they send out, the destination MAC address is the VMAC. And where is the VMAC? The SW will check its MAC table. Okay, find out. The VMAC is at interface G001. So send to the left side, firewall 1. And firewall 1 send to its uplink. Maybe another switch. All right. Okay, and if the link, the left side, the forwarding path, one of the node or one of the link is down, for example, this link is down or that link is down, okay, just this link is down, this link between firewall 1 and SW1, the VRRP message cannot received by the firewall 2. Because when the VRP group enable, both two firewall will send the VRP message to each other. The first step is to do the election to find out which one is the boss, which one is active and which one is backup. And the firewall, the device which have the higher priority will become the active one. Okay, and after the election is finished, the active device will keep sending the VRP message through SW to the firewall 2, and firewall 2 receive that. Okay, he just realized, okay, my boss, the active one, is still alive, so I'll stay at the status of backup. I won't become to the active. So by default, the firewall 2 will not transfer any traffic. But the link between the firewall 1 and the SW1 is down. So the firewall 2 can no longer receive the VRP packet from the FW1. After 3 times waiting, the FW2 realized that, okay, maybe my neighbor, my boss, the active device is down. So I will become the new active device. Then, at the same time, the firewall 2 have the permission to control the VIP and also VMAC, VIP. And the firewall 2 send the gratuitous ARP to the SW and refresh its MAC table. Before the accident happened, the VMAC address is mapping to the 001 port, right? And it is because the firewall 2 becomes active, and firewall 2 send gratuitous ARP and update this entry. So now the VMAC will corresponding to the interface 002, right? 002. So the traffic will go this way, the right side. All right. But VRP also have the issue, also have one issue. Also have one issue. If we create 2 VRP group, VRRP group 1 and VRRP group 2. And the issue is between the VRP group and VRP group, they have no idea of each other. They cannot realize there is another VRP group. So if one VRP group status change, maybe the firewall 1, by default, the VRP group 1 active is the firewall 1, and firewall 2 is the backup. And for the VRP group 2, the firewall 1 is also an active device, and firewall 2 is backup. If the link of this one is down, okay, VRP group 1, firewall 2, backup shift to the active. But I said between the VRP group and VRP group, they have no idea of each other. So the VRP group 2 won't change, still remain the status. Firewall 1 active and firewall 2 backup. So what will happen in this case? Okay, so the traffic will send to the firewall 2, right? Because now the firewall 2 is the active one, and send to the switch 2. Yeah, this is the go direction. Come and go, all right? And when the traffic back, the SW2 will check its MAC table to see where is the next station. But the VRP group 2, the VIP, is still owned by the firewall 1, right? And VMAC is still here. The VMAC2, right? VMAC2, VRP group 2 is VMAC. So the SW2 will still send traffic to this way, to firewall 1. But the firewall 1 downlink is down. So the traffic is blocked. The business is down. The reason why this thing happened is because the VRP group and VRP group cannot synchronize their status. So we need to use another technology to fix this, and that is VGMP. VRP group management protocol. And the function of this one is when firewall 1 and firewall 2 generate 2 VRP group, both 2 VRP group will put into that VGMP group. And VGMP will control the status of all the VRP group. If one VRP group status shift, status change, another one change at the same time. So if we enable the VGMP, the VRP group 1, firewall 2 becomes the new active device. At the same time, the VRP group 2, firewall 2, will also shift, become the new active device. And then the traffic can go the right side. All right. And that's VGMP, synchronized VRP group status. Okay, and it still have one issue. We still have one issue. It is because the firewall's key technology, stateful inspection mechanism, and the key point of this mechanism is the firewall will check the first packet, right? When the firewall received a message, first step is to check whether this packet can match a existing session entry. If there is no session entry can be matched, then the firewall 1 try to check out find out this packet is the first one or not the first one. If it is the first one of one data stream, then match the security policy. And if the security policy matched and the action is permit, then the firewall will let this packet pass through and send out from one interface and then generate a session entry. And the rest data string, the rest of the packets in this data string can match that session table. The firewall 1 just generated. All right. And that's stateful inspection mechanism. So the key point in this case is the firewall will check the first packet, right? And the firewall 1 and firewall 2 by default, no synchronization of the session entries, right? Which means when firewall 1 is the active device, yeah, the firewall 1 will transfer a lot of traffic, and so many packets and generate hundreds, thousands, millions of session entries. But firewall 2 has no traffic, right? So the firewall 2 do not have any session entries inside of its session table. So when the switch happened, the traffic immigrated to the firewall 2. When the data string arrived to firewall 2, the firewall 2 just check whether these packets were the first packet or not. And it find out it's not the first packet, right? And drop it. Then the business will down for several seconds or half minute or 1 to 2 minutes, depending on the packet sending frequency. So this is the issue. The firewall 1 and firewall 2 don't synchronize its session entry. So the traffic will down for a little time. So in order to resolve this problem, another protocol imported into this case, HRP, Huawei Redundancy Protocol. And the function of this one is easy to know because I already said the problem is the firewall 1 and firewall 2 cannot synchronize the session entry. So one of the function of HRP is to synchronize their session table in real time. All right. And if we deploy this one, which means we need a link connect between the firewall 1 and firewall 2. And this link is used to synchronize the information. All right. And when the switch happens, the firewall 2 already have those session entry. So the traffic will not down. And that's 3 key technology: VRRP, VGMP, and HRP. Okay. Am I clear? Am I clear? Am I clear? Yes. Okay, good. And we can check the training slide. And one thing I need to tell you is that HRP, the HRP is the Huawei made protocol. It is a private protocol. If we're using the Cisco, there is no HRP. But I believe the Cisco devices, router or the firewall, also have the similar mechanism, just like the HRP. But the name is not HRP. I believe every vendor will create their own solution, will develop their own solution. And Huawei is called HRP. Okay. I said one of the HRP's function is synchronize the session entry and session table, right? But this is not the only function. Actually, the HRP can synchronize a lot of information, and such as the NAT policy, security policy, authentication configuration, ASPF, almost all the configuration. the active device can synchronize to the backup device, but not all. I said almost, but not all. For example, the interface configuration cannot synchronize from the active one to the backup one, right? Because they enabled VRP and VGMP, but that does not mean the IP address is the same. They still need a different interface IP. So the IP address of one interface cannot synchronize from the active device to the standby device. All right. And also, they can the firewall once enabled HRP, they can synchronize the objects such as the address group, service and service group, application user, so many things, and including address pool. All right. And the root information by default will not synchronize to the remote side, but there is a button, there is a switch. If we turn on that switch, okay, then the static root can synchronize to the remote side. See that? HRP auto sync config static root. And also IPsec and SSL VPN can synchronize. Okay. And I think I can show you something, show you the practice, how to use the HRP, function through a ENSP practice. Okay. Here is the topology. First, we need to drag to USG 6000 V. All right, 6000 V, not USG 5500. This is the Asian version. We do not use this anymore. Now is this one, USG 6000. And a cloud. The cloud is the bridge between the ENSP application and our desktop. Okay, because we want to use the Chrome, the web browser, to control the firewall 1 and firewall 2. Okay, to switch. And PC. First, we configure the cloud. Bind info, UDP, add, Ethernet. Choose it and add, and UDP again, add. And there are 3 ports, 2 UDP and 1 Ethernet IP address port. Okay, and we bind the port number 1 and 2 as one pair, and bind the port number 2 and 3 as another pair. Okay, 1, 2, two-way channel, add. Okay, 2, 3, two-way channel, add. Okay, finished. Then we connect the cloud to the firewall 1 and the firewall 2. But we enabled firewall 1 and 2 first. Okay. And actually, you can try to do this with my step. Uh, it is not a very complicated practice, all right? Not so complicated, just HRP. Okay, I believe you have noticed something. When we try to deploy the hot standby technology between two firewall, and we need to keep the device type, software version, even the interface number, these two firewall need to keep the totally same, all right? For example, the firewall 1 and firewall 2, both connected to the SW1. This is the uplink. And uplink, they use the interface G100, all right? Still waiting. And the downlink, both firewall 1 and 2 use the interface GE101 connected to the SW2. And also, the link between the firewall 1 and firewall 2, and that is used to transfer the HRP information. And it is called the heartbeat line. Heartbeat. HERT. Oh, seems like the firewall 1 is not good. Huh. I'll use another one. Cannot start. Huh. This is embarrassing. I'll delete this. Delete it. And the heartbeat link. And you can also find the heartbeat link, both firewall 1 and firewall 2, using the interface number GE102, right? Okay. And we also need to design the IP address. For example, now the PC1 try to access the PC2. This is the requirement. The PC2, we assume that it is a internet PC, and PC2 IP address, maybe 20.1.1.1, 10, 100, in order to distinguish from the VRP interface IP, all right? And PC2 IP address, it is a private network, right? So it is 10.1.1.100 /24. Figured 10.1.1.100 and subnet mask 255.255.255.0 and gateway 10.1.1.254. All right, gateway. Okay, and for the PC2, the gateway should be 20.1.1.254, right? Okay. Oh, Then we enable the switch 1 and switch 2. And now it's about time to design the VRP group, right? VRP group. And obviously, there are two VRP groups. Okay, this is VRP group 1. Blue. Red. And this is VRP group 2. VRP group 1. And the VIP of this group, VIP, is 10.1.1.254, right? Okay, and VRP group 2, VIP is 20.1.1.254. Okay. PC also need to turn on. And the physical IP address, the IP address configuration for the FW1, the VRP group 2, interface G100, the IP address should be 20.1.1.1/24. And the security zone untrust. All right. This is the attribute of interface G100, which is connected to the uplink SW1. All right. And the FW2 interface G100, almost the same, but the IP address, the interface IP address should be 20.1.1.2, all right? Okay. And the VRP group 1, easy. Interface G101, IP address 10.1.1.1/24, and zone trust. All right, trust. And firewall 2, 10.1.1.2/24, and zone trust. Okay, another thing, the last pair of IP address is the heartbeat line. The heartbeat line, which is interface G102, and firewall 2, interface G102. And we assume that the heartbeat IP address is 192.168.1.1/24. Okay, and security zone, we assume that is DMZ, or we can create another security zone, HRP, all right? It's okay. In order to save the space, 1 and 2. I think you can understand, right? 1 is firewall 1, and 2 is firewall 2. Zone HRP. This HRP we need to create. It is a new security zone, all right? As for the security priority, you can define by yourself, okay? Yeah, then we finish the design of this topology. Then we can configure, right? We can configure. Oh, sorry, the PC2. I haven't configured the IP address and gateway. Gateway 20.1.1.254. Apply. Firewall 1, double click. Do you still remember how to do the authentication? The first step, a credential. Admin, this is the default user. And the default password, admin at 123. The first A is uppercase. And we need to change the password. Please enter old password. Again, admin at 123. And please enter new password, huawey at 123. Please confirm new password. Okay, huawey at 123. Yeah. And system view. Sysname FW1. And interface G000, right? It seems so familiar, right? Because we have do these steps several times. Every time I try to show you something, the first step, do the initialize configuration, set the interface IP address, and permit ping, permit HTTP, permit HTTPS, right? Okay. And it is firewall 1. Default IP address is 192.168.0.1, right? And there's no need to change the firewall 1. But firewall 2, we need to change the manage IP address, okay? Service manage ping permit. Service manage HTTP permit. And service manage HTTPS permit. Okay. And here is the configuration of the interface G000, which is the manage port, all right? And the firewall 2, same configuration. Same configuration roadmap. Username admin at 123. Yes. Old password admin at 123. New password huawei at 123. Huawei at 123. Okay. Sysname FW2. Interface G000. But this time, the FW2, we need to change its manage port IP. Because if we don't change, then the FW1 and 2, the manage port IP is the same, right? Duplicate. We modify the IP address 192.168.0.2, all right? 24. And service manage PIM permit. Service manage HTTP permit. Service manage HTTPS permit. Okay. Finished. Then we can, this is not, yeah, almost done for the command line part. Then we move to the Chrome. Move to the Chrome. HTTPS. Yeah. And HTTPS 192.168.0.2. And pay attention, the port number is 8443, not 443, all right? Username admin. Password huawey at 123. Login. And username admin. Password huawey at 123. We log into the firewall 1 and firewall 2. Okay, now we need to start from the firewall 1. Okay, first step is to configure the interface and security zone. All right. And according to this topology, we need to create a new security zone, right? And that's HRP. So we do so. Network. Zone, right? Zone. Add a new one. Zone name, HRP. And priority, we set this priority as 60, right? And you can also set the value whatever you want, maybe 20, maybe 30, 40, not 50, because 50 is duplicated with DMZ zone. Okay. Then we modify the interface configuration. (100) uplink, 101 downlink, 102 heartbeat. Okay, so first 100. Zone should be untrust, right? Untrust. An IP address 10.1.1.1. Oh, sorry, it should be 20, not 10. 20 /24. Okay. Pin permit. Yeah, and 101. 101 is downlink. I used to connect to the PC1, the private network. So zone should be trust. Trust. An IP address 10.1.1.1/24. And the pin permit. Okay. And the interface 102. 102. 102. Zone HRP, right? HRP. IP address 192.168.1.1. Okay. Yeah, then we finish the configuration of the basic part, IP address and zone. And then firewall 2. Firewall 2. Network. Zone. Add. HRP. Priority 60. Okay. And interface 100. Security zone. Untrust. IP address 20.1.1.2/2024. And pin permit. And 101. Virtual, sorry, not virtual system. Zone should be trust, right? Trust. 10.1.1.10. 24. Pin permit. Okay. Yeah. And 102. HRP. 192.168.1.2. Pin. Okay. It seems like we finished the configuration of the basic part. Then we try to enable the HA function, high availability, which means the dual system host standby. And where is the configuration view, system, all right? System, click it. And where is the HA? Okay, here it is. See that? High availability. Click it. Dual system hall standby. And there are several choices, IP link, BFD, and link group. And we just use the first one, dual system hall standby. Okay, by default, the dual system hall standby function is turned off, is off, right? By default. And we need to turn it on. Edit. Click this button, edit. Dual system hall standby. Enable. All right, enable. And operation mode, active and standby backup, or load balancing. After this practice, I will show you the second mode, load balancing, which means the firewall 1 and 2 can forward the traffic at the same time. All right. But now we just use the active and standby mode. The active device, the active firewall, forward all the traffic, and backup no traffic. And default status, active or standby, which means for the firewall 1, which role we want to set to this firewall. And of course, according to the topology, the firewall 1 is the active, right? Sorry, active. And firewall 2 is backup. So now we'll configure the firewall 1. So the default status we select active, no need to change. And then heartbeat interface, which means heartbeat line, right? Heartbeat line. Do you still remember the port number for the heartbeat interface? Interface G102. See that? IP address 192.168.1.1. And peer IP address, which means I need to tell the firewall 1 what is the firewall 2's heartbeat interface IP address. 192.168.1.2. Right? We need to specify this one. Okay, proactive preemption. I'll explain that later. By default is enabled, this function. And then, see that? Configuration interface monitoring and configuration virtual IP address. And first we configure this one. Virtual IP address, which means VRRP, right? And see that? What is VRID? The VRID means the VRRP group number. And that is VRID. Add a new one. And in this case, we need to create 2 VRRP groups, right? So we need 2 VRID. But first, we just define the first one. The VRID is 1, all right, 1. And interface, VRRP group 1, right? And interface should be GE101. Okay, then we choose 101. 101. See that? This is the physical, real IP address. This is the real IP address of the interface G101, 10.1.1.1, right? And we need a VIP, virtual IP address, right? And it should be 10.1.1.254. And this is also the gateway IP of the PC1. See that? Virtual MAC enable. If we click, we choose this one, then the firewall will set the VIP MAC address as the VMAC format, 0000-5E00-010, right? And OK. And we just finished the configuration of one of the VRP group, VRP group 1, right? And we still need another one, VRP group 2, the same configuration method. VRID 2 interface G100, right? 100. And IP address 20.1.1.1. VIP 20.1.1.254. Virtual MAC enable. Okay. And configure interface monitoring, which means we need to track. We can track the status of the physical interface. When one interface, which is tracked by the HRP, is down, then the HRP will switch. The active device will switch to the backup, and backup becomes the active. But which interface we want to track, we can add, all right, set a category. Interface. It should be downlink and uplink, right? We want to track the status of uplink and downlink. 100 add, and 101 add. Okay, right? Now the status is okay. See that the icon is green and up, and that's finished. Okay. And it is because we just finished the configuration, the HA, the dual system host standby configuration, just on firewall 1. But firewall 2 haven't been configured, right? So the status is error. We need to finish the firewall 2's configuration. And the same configuration method. First, we find the system. And high availability, HA. Dual system host standby. Edit. Enable. Turn on the function of dual system host standby. And operation mode, active and standby. Default status. Firewall 2 is a standby, right? We want to set the firewall 2 as the standby. So we click this one. Standby. Okay, and heartbeat interface. Interface G102. And peer IP address, which means the firewall 1, the heartbeat interface. 192.168.1.1. Okay, and VRP group. The first is VRP group 1 in the interface 101. 10.1.1.254, and this is the VIP, and VMAC enable. Okay, and VRID2, VRP group 2, interface 100. Okay, VIP 20.1.1.254. Virtual MAC enable. Okay, and then track, monitor the interface status of interface 100 and 101. Track them. Interface 100 add, and 101 add. Okay. Okay. Yeah, then we finished the firewall 2 configuration of HA, right? And let's back to the FW1 to refresh the status. See that? Monitor item of the HA function. Current running mode, active and standby. Current working role, active, right? And let's see the firewall 2. Current working role, standby. And back to the FW1. Heartbeat interface, G102. Proactive preemption, enable, all right? And virtual IP, VRP, two VRP group, right? 10.1.1.2.4, 20.1.1.2.4, and detail, the status is master. And master means active. And we can have a test. We're going to have a test. Now I'm going to use the PC1, try to ping the PC2. $20 $100. It seems like we're missing something, right? Seems like we're missing something. Huh. So what is the problem? What is the issue? Why? Request timeout. Huh. I think Cisco is HSRP. Maybe, yes, HSRP. Okay, actually, I forgot to configure the security policy. So, security policy. Then I can show you something. Okay, see that? Firewall 2, the policy, just a default one, right? There is no security policy can allow the PC1 try to access PC2, right? Okay. And I said, since we enabled function of HA, the HRP, then the configuration can synchronize from the active device to the standby device. And which means I just need to configure the security policy once. No need to configure twice, right? Okay, then we try to configure the FW1 security to create a security policy. See that? Policy, security policy, add security policy. Name, PC1 to PC2. Source zone, trust. Destination zone, trust. Source IP address, 10.1.1.100. Okay. And destination address, 20.1.1.100. Okay. Service, ICMP. And okay. See that? Now on firewall 1, we generate a security policy. And then let's see the firewall 2. Refresh it. See that? The security policy just synchronized from the firewall 1 to firewall 2. And the configuration is totally same. Totally same. All right. Okay. And then let's try to ping. Oh, okay. The first packet lost is because the ARP. All right. Okay. For now on, any questions? For now on, any questions? Hello? Is that clear? Okay, good. It's always ARP fault. Yeah, no questions. Yes, it's about ARP. It needs time to exchange the ARP information. So the first 2 packet lost. Okay, then I'm gonna show you the forwarding path. Because I set the firewall 1 as the active device and firewall 2 as the backup, which means the traffic should go through the firewall 1, not firewall 2. And let's prove it. and we should catch the packet of firewall 1 interface G100, okay, 100. And catch the packet on the firewall 2 G100 to prove it. Okay. And the first window belongs to firewall 1. And the second Wireshark window belongs to firewall 2. Then ping. Okay, then check the result. See that? The firewall 1, we can catch all the ICMP packet on the firewall 1, right? Request and reply. But on firewall 2, nothing, right? Nothing, just a VRRP announcement. VRRP announcement. And that's the VRP packet. But no ICMP packet. Without ICMP packet, right? Okay. And let's check the SW information. Because I want to switch. I want to simulate a network failure. Maybe I can shut down the interface of or I can just delete the line between the SW1 and firewall 1. But before that, I want to show you the MAC table of one switch. SW1, display MAC address. See that? Display MAC address. Did you see the second one? 0000 5E000102. And this is the VMAC of the VRRP group 2. And it is because the VRP group number, the VRID is 2, right? So the last number of the VMAC is 2. And this VMAC address is learned from the port number GE001. I mean the SW, the switch 001. Where is 001? Here, right? This interface, which means the gratuitous ARP is sent by the FW1. And let's check where is the gratuitous ARP. See, this is the gratuitous ARP. See that? And sent by the firewall 1. MAC address, and it is broadcast. Destination MAC address FFFFFFF, which means all the PC in this broadcast domain can receive this gratuitous ARP. And sender IP address 20.1.1.254 and target this one. And the MAC address, this one, right? 5000005E00101. This is gratuitous ARP. Okay, and we can also check the SW2. SW2, display MAC address. Yeah, there is another one. 00005E000101. And this is for the VRP group 1. And it is learned from the port GE001, right? 001. Here is the 001 on switch 2. So the traffic go to the left side. All right. Wait a minute. I need to take a screenshot. Okay, then I'm going to do one thing to simulate the network failure to see what will happen. All right. Now I'm trying to delete the line between the firewall 1 and SW1. This line, I'll remove the connection. I will remove the connection. And let's see what will happen. Okay. First, we check the status. We check the status of firewall, to firewall. See that? Now the firewall 1 current working rules is standby. It is because the network failure, the VRP group 2 changed to the standby. And firewall 2, the firewall 2, check it. High availability. See that now the firewall 2 is the active, And then let's check the SW2. Before I plug out that link, before I delete the link, the VMAC is learned from the interface G001. This interface, right? This interface. What about now? See that? 0000-5E00-0101. Now it's learned from interface G002 because the firewall 2 sent the gratuitous ARP to the SW2. And this is 002 interface. All right. And let's check the PC ping. Yeah, it's okay, right? It's okay. And the traffic, then we check the second window. Request and reply. Send the traffic just across through the firewall 2 and not across through the firewall 1, right? Okay, then we can link this back. 01-100, yes. Okay. Now the link is recovered, right? The link is recovered. After 1 minute, the firewall 1 will resume the status of active. And let's check. Firewall 1. Now it's still standby, right? Still standby. Refresh. See that? Backup, standby. And see that? Should be master. Waiting for 1 minute. 60 seconds. Keep refresh. Oh, 1 minute can be so long. Okay. See that? Now it turns to active. And firewall 2. See that? Before I recover the link is active. Now is standby, right? Why? The firewall 1 will turn back, will become the active again. It is because when we configure the HRP, we enable this thing, proactive preemption, which means the active device failed, right? One link failed. Yeah, it changed to the backup. And when the network failure resolved, which means the link recovered, it will go back to the active status proactively. And that's the function of proactive preemption. If we don't enable it, disable it, then they will not change. They will not change automatically. If we need to change, we need to change shift the status manually. All right. Proactive preemption. Okay. 1 minute. Any questions? Any questions for now on? Am I clear? All clear. Okay. Then let's take a break. Take a break. Ten minutes. All right. 10 minutes break. I wanted to ask you if you could please add me to the ELAB class. Oh, actually, I have already told the ELAB manager several days ago. It seems like something wrong. There is some issue. Okay, since you tell me, I will help. I will find the ELAB guy. Try to fix this. Okay. Maybe tomorrow. Maybe tomorrow you can use the ELAB. But today the ELAB guy, uh, he just got off work. So maybe tomorrow he can fix this. This is your name, okay. And please make sure you use the email you send me to log in. And the rest of you, can you open the ELAB? Oh, lagging. Because of the high latency. Do you need time to practice? Do you need time to practice this one? If you need time, you can, I'll give you 30 minutes. Try to play this one. Okay. Then 30 minutes practice. And if you have question, send me message. I can see that.
Obtén todo lo que necesitas para triunfar online con las ofertas de Black Friday en Hostinger. Planes de hosting web desde solo $2,29 al mes. Publica tu...
Sé sincero, seguramente alguna vez te ha pasado que has intentado abrir un PDF pero no has podido porque no a desbloquear un PDF sin saber la contraseña, ojito, y lo mejor sin instalar ningún programa, aunque después te tengo que comentar algunos consejos que debes saber. Muy fácil hacerlo. Pues aquí, como veis, tengo un PDF cuya contraseña no recuerdo, con lo cual no lo puedo abrir, pero hay una solución que es ir al apartado de desbloquear PDF en formatpdf.com. Te dejo como siempre el link en la descripción y como siempre vamos a seleccionar nuestro documento y subirlo al servidor. Una vez que lo tenemos cargado, como veis, detecta que es un PDF con contraseña y lo único que vamos a tener que hacer es pulsar en desbloquear para poder acceder a nuestro documento. Tras unos segunditos, como veis, aquí tenemos ya el documento desbloqueado. Para descargarlo lo vamos a guardar, lo vamos a abrir y como veis ya lo podemos visualizar de un modo muy sencillo. Ahora te explicaré esos consejos que te he mencionado antes, pero te voy a comentar que en el móvil evidentemente podemos hacer lo mismo. Gracias a la web de Format PDF que
Hola Freddy, buen día. Bueno, sí, digamos, ¿no? 3 horas ya, nada más que no hay pues los docentes. Han habilitado horarios de 7:30 a 10:30. Ese digamos paralelo A y como paralelo B está de 18 a 21. Entonces, sí, no, he estado revisando en el sistema, hasta ahora no ha salido el cronograma donde nos dicen qué día tenemos que inscribirnos. No ha salido nada, te cuento.
No saco la Glock y si saco para usarla, yo no me voy más, llévala por mi habla. Encajo perfecto cada una de mi barra. Y como a tu perra tengo amarrada en mi cama. No saco la Glock y si saco para usarla, yo no me voy más, llévala por mi habla. Encajo perfecto cada una de mi barra. Y como a tu perra tengo amarrada en mi cama. Quiero 1 millón, quiero tener el Mercedes.
Okay. It's already 30 minutes, right? I believe if you listen to my class, I think you have already finished the configuration, maybe. And if you have question, it's okay. Just tell me, all right? Just tell me. You can prepare your questions and type and copy and paste and send in the chat box and I can answer you, all right? And that's the basic scenario of HRP, dual system host and buy. Just the basic version. Actually, it is based on VRP. Based on VRP. And what about load balance? VRP load balance. And if the downlink and the uplink device is not switched, if it is router, what will happen? Okay, let me introduce you. I just introduced you the basic part. If you're interested in the next part, you can listen to me very carefully. All right. Maybe it can help you to deploy your live network. If you're prepared to buy some Huawei firewall or some Huawei devices, maybe can help you. Now the scenario changed. Firewall 1 and firewall 2. Oh, before I introduce you the scenario, somebody told me that they cannot log into the eLab, and please send me your email account and your login name. And tomorrow I'll find the eLab guy and let him to fix this issue. I'm so sorry to hear that you still cannot log in the eLab. If you find the problem, just let me know and I'll try to fix it. Try to fix it at the first time, all right? FW1 and FW2. Switch. Switch. And in this topology, the firewall 1 and firewall 2 enabled VRP, and the working mode is active and standby, right? Active and standby. But what if I want to prove the usage I want to prove the usage of the devices. And maybe the traffic trying to pass through this pair of firewall is so large, increasing day and day. Just keep increasing. And maybe today, my traffic, the peak rate usage is 80%. And next day, 85. Next month, 90, 95. So if we cannot extend the device, why not we're using the firewall 2? For example, now the traffic, just the peak rate is just 1 GB per second, 1 G per second. And what if we deployed another network system and more users try to use our services, which means we need much more bandwidth, right? We need much more bandwidth, and 1 G is not enough. Maybe I need 2 G. And improve the network usage. So we need to consider about the load balance mode. Load balance, which means at the same time, firewall 1 and firewall 2, they can forward traffic both. All right? And still using the VRP. But how to achieve this? Actually, the answer is easy. In the load balance mode, firewall 1 and firewall 2 need to establish 4 VRP groups. Maybe 4 VRP groups. Let us see. Okay. PC. Internet, maybe internet device, all right? Maybe a router. If we want to achieve load balance, we need to create 4 VRP groups. VRP group 1. Group 1. And VRP group 2. VRP group 3 and 4. And for the VRP group 1 and 2, the active status was on firewall 1. Active. But for the VRP group 4 and 3, the firewall 2 is the active one. All right. Which means in this scenario, we have 4 VIP. We have 4 VIP, right? And for those PC, the downlink PC, they can choose the gateway, 2 gateway, right? They can choose 2 gateway. Maybe on the left side, I have 50 PCs. 50 PCs, all right? And they will use the VIP as the gateway. They choose the VRP group 1 VIP. And at the right side, I still have 50 PCs. So totally is 100 PC, but the gateway is different. The first 50 PC, they use the VRP group 1 VIP. And the second PC, they choose the VRP group 3 VIP as the gateway, which means the traffic sent from the left side go this way, and the traffic sent from the right side go this way. Load balance. Load balance. But this scenario have one issue, is that we need to modify the PC's gateway manually, right? And manual mode. That is to say, for the PC1 to PC50, I set the gateway as the VIP1, VRP group 1 VIP. Maybe is 10.1.1.254. All right. And for the PC2 to PC, it should be 51. PC51 to PC100. All right. Their gateway, I choose the VRP group 3 VIP. And maybe the VIP is 10.2.1.254. All right. And the group 2 and group 4 at the uplink, same. All right. And for this router, it can roll down 2 static route, equivalence route, equal cost route. The first route, the next hop is the VIP 3. Let me check. VIP of VRP group 4. We assume that the VIP for this one is 20.2.1.254. And for the VRP group 2, the VIP is 20.1.1.254. And for the router, for this router, it can roll down 2 static route. Go this way or go this way. Next hop, I can set the next hop as 20.2.1.254. And another route, the next hop, 20.1.1.254. All right, but this mode is quite complicated, a little bit complicated, because it's hard to control the traffic at this side. The uplink is hard to control the traffic because I need to do a lot of configuration on this router, because I have to guarantee the green line, the green traffic. Yes, the green traffic, the PC can choose its gateway, right? Yes, they can choose the traffic to pass through the firewall 1. Yes, it's sent to the router. What about the reply traffic? The reply traffic, it needs to go back to the left side, right? So sometimes it's hard to control, how to modify the route information. If I just roll down a 2 static route, so the next hop actually is random. Maybe the reply packet will go this way, and maybe the reply packet go that way, which means the come and go forwarding path is not the same. This can cause some problem, and it is not good sometimes. So in order to fix this, actually it's about design. In this scenario, it's about the design. For example, the network segment of PC1 to PC50, maybe I can use one network segment, for example. 10.1.1.254. Yes, just 10.1.1.254. And the PC51 to PC100, the network segment is 10.2.1.0/24. This is network segment for the right side, and this one, oh, sorry, is 10.1.1.0/24. Two network segment. So on the router, I need to roll down two static route. The first static route destination is, for example, IP static route. (10.1.1.0) 24, and next hop I choose the 20.1.1.254. Okay, this is the route for the left side, and I also need to define another route, another static route, and it is 10.2.1.0/24, and next hop 20.2.1.254, which means the red traffic will go the right side. That's the way, all right, to roll down two static route. And next hop is different. Destination different. Destination mapping to a specific next hop. That's the way. And it seems not so intelligent, right? It seems not so intelligent. Okay, and this is the load balance. How to deploy a load balance mode on firewall based on the VRRP mode. All right. Any questions? Any questions? Am I clear? It's a little bit complicated, but the logic is simple, right? Load balance, I just need to create 4 VRP group. Group 1 and group 2. Group 1 and group 2. The active status on the firewall 1. Group 2 and group 4, group 3 and 4. The active status on firewall 2. Half traffic go the left side. Another half go the right side, right? Oh, someone offline. It seems like someone offline. Okay, since you have no question, if you don't ask me, I think maybe you have no question. Then to the next scenario. Firewall 1, firewall 2, router. This time is not switch, is router, all right? In this case, how to achieve active and standby, and how to implement the load balance. Router, see, it's L3 device. It's not L2, which means we cannot use the VRRP anymore. In this scenario, if the downlink and uplink device is router, then we cannot use VRRP because the interface on router is layer 3. The router have the router's interface do have IP address, but the switch, the interface do not have IP address. So the network segment between firewall 1 and router 1 is one network segment. And firewall 2 and firewall and router 1 between them is another network segment. But VRRP need us to create a pair of real IP address and one VIP in one network segment, right? But in this scenario, we have two network segments. And maybe this is 10.1.1.1. Okay, a 10.1.1.2. And this is 10.2.1.2. And this is 10.2.1.1, right? Different. So we cannot use VRP. But how? Since we can't use VRP, how? The answer is OSPF. We can generate a OSPF among these four devices. Firewall 1, 2, and router 1, 2 run OSPF. And we know the OSPF can calculate and generate the root information by itself. So for these four routers, four devices, they can generate the root information. And for the router 1 and router 2, they will receive the root information both from firewall 1 and the firewall 2. For example, router 1, if the router 1 try to access the PC1, all right? For example, the PC1 IP address 100.1.1.1. Then the router 2 will receive this destination root information both from firewall 1 and the firewall 2. And the cost value is the same. And that is to say, the router 1 can send traffic to the PC1, go this way and go this way. And this is the load balance. By default, if the firewall 1 and firewall 2, router 1, router 2, deployed OSPF, then it is load balance mode, right? But what if I still want active and standby mode in this case? Still easy. At the firewall 2, we can enable a function. Do you still remember the VGMP? One of the functions of VGMP is to control the VRRP group status. But in this case, the VGMP group have another function. It can change the cost value of the standby firewall, which means the firewall 2, when the firewall 2 send the root message to the router 1 and router 2, the cost value will higher than the firewall 1. And the cost value, the root information cost value is the lower the better, right? So in this case, the router 1 and router 2 will choose this way to go. Yeah. Okay, and let me show you. Maybe it's a little bit complicated, right? If I just say so is hard to understand. So let me show you. And after that, the whole standby part is finished. All right. This time, I'm going to use two router 1 and router 2. Okay. And we need to redesign the IP address. Let me think about it. And first, we need to cancel the HRP function. Delete the configuration of HRP and the interface. Because I want to show you the second scenario. If the downlink and uplink is not switch, it's router, how to deal with it. Okay, delete those configuration. And okay. And firewall 2, same. And also the network. I need to delete the IP address. Actually, I think for the firewall 1, okay. The Zoom security zone configuration is good. Untrust and trust and HRP. The zone part is good, but I need to modify the IP address. All right. For the link between the router 1 and firewall 1 and router 2, it should be network address 20.1.1.1 and .2. Okay, that's good. And 2. And for the IP address between the firewall 2 and router 2, I'm going to use the 40. All right, 40. 1 and 2. And the downlink, I'm going to use the 10 and 30. 10.1.1.1, okay, and 2. 30. And the router 1 and 2, firewall 1 and 2, RAM OSPF. And there's a circle. OSPF. And the PC1 and PC2, I need to change the IP address. Now it's 200.1.1.1. 200. And gateway, 254. It's okay, 254. And for the PC1, it's 100.1.1.1. Gateway, 100.1.1.254. Yeah, Then we change the configuration, PC2. And IP address of the router 1 and 2. .40. Okay. And let's do the configuration. First, we configure the router 1. All right, router 1. Oh. Okay, router 1. Sysname, router 1, R1. And IP address, First, interface G000. IP address 10.1.1.2. 10.1.1.2, 24. Okay, and interface G 001. 001. IP address 30.1.1.2/24. Okay, and interface G002. IP address 100.1.1.254. And test. Yeah, good. And we enabled OSPF. OSPF 1. Router ID 1.1.1.1. Area 0. Network 10.1.1.0. Okay, and network 30.1.1.0. Yeah, that's the way to configure the OSPF. Very easy, right? Very easy. Just actually just 4 command line, right? Just 4. First, enable OSPF and specify the router ID and area 0. This is a backbone area. And network 10.1.1.0 and networks 30.1.1.0. All right. Okay, and router 2. The same configuration. Interface G000. IP address 20.1.1.2. 24. Interface G001. IP address 40.1.1.2. And interface G002. IP address 200.1.1.254. Oh. And test. Yeah, good. And the OSPF 1 router ID 2.2.2.2. Area 0. Network 20.1.1.0. And network 40.1.1.0. Okay. Router 2. And then firewall 1 and firewall 2. Actually, the configuration way is the same. This time I'm going to use the command line. It's much more faster. Interface G100. IP address 20.1.1.1. 24. And interface G101. IP address 10.1.1.1. 24. Already exists. Yeah, don't need to modify. No need to modify. And OSPF 1 router ID 3.3.3.3. Area 0. Network 20.1.1.0. And network 10.1.1.0. Yeah. And for the OSPF protocol, by default, it can pass through the firewall. Do not need to deploy a security policy for OSPF. All right. Okay, let's check the OSPF neighbor. Display OSPF peer. Okay, yeah. 2222 and 1111, which is router 1 and router 2. Router 1 and router 2. And the status, the state is full, which means established. Okay. And oh, I forgot something. For the router 1, I still need to network the 200.1.1.0. Yeah. And for the so it should be 100. Network 100.1.1.0. Router 1. Router 2. Area 0. Network 200.1.1.0. Okay. And for the firewall 1, let's check the IP routing table. Okay, the firewall have already learned the root information of 100. And where is 200? Here is 200, right? Yeah, which means OSPF is running good, running well. And firewall 2, same configuration, but we need to modify the IP address and enable OSPF. Interface G 100. Okay, IP address, it should be 40.1.1.1. 24. And interface G 101 IP address. Display Oh, I'm sorry. Because of the network issue, I'm offline for a while. Offline for a while. Now I'm back. Let's continue. IP address. I'm modified the interface of firewall 2. Yeah, it should be .1. Display IP interface brief. Yes, good. And OSPF1 router ID 4.4.4.4. Area 0 and network 40.1.1.0.0.0.0.255. And network 30.1.1.0. Okay. And after several seconds waiting, the firewall 2 established the OSPF neighbor with router 1 and router 2. And we can display OSPF peer to check the status, right? 2222 and 1111. And these two routers are the router 1 and router 2. And the state is full. All right. Okay. And actually the configuration is almost finished. But the security policy is about time to re-enable the HA configuration. Dual system host and bar. Okay, this time a high availability dual system host and by. We go back to this configuration view. Edit. Enable the host and by. All right, enable host and by. But the operation mode, we can choose load balance. We can choose load balance. All right, and heartbeat interface 102. Okay. And firewall 2. Configuration is very easy. For the L3 mode, if the downlink and uplink is router, it's easy to configure. Oh, it's wrong. Okay. High availability. Edit. Enable the function and choose load balance. Load balance. And the rest part, keep default configuration. And OK. And let's refresh. Active, right? Active. Current running mode is active in standby. But the current working rule is still standby. Just ignore it. Just ignore it because this is some kind of small bug. All right, some kind of small bug, but it's okay. The firewall 1 and firewall 2 now is working at the active and it should be load balance. Let me check. Yeah, load balance. Yeah, load balance. Let's check. Firewall 1. It's a small bug. M, yes, M. S. Okay. And let's check the root information on router 1. Display IP routing table. Uh, 100. Yeah, here. See that? On router 1, when I check the root information of 200.1.1.0, which means the root information of PC2, right? And I can see two equal cost root information. And this is equal cost root, equal cost, which means for the router 1, there are two options to go to 200.1.1.0. The first and next hop is 10.1.1.10, which is firewall 1. And another option is 30.1.1.1, which is firewall 2. And that's load balance mode. And on the router 2, when we check the routing table, see this 100.1.1.0, and that's the network segment of PC1, right? PC1 for the route. I'm looking at the router 2's configuration. For these two routes, the next hop, two options. First, go firewall 1, and second, go firewall 2, right? Okay. And we can test. I'm going to use the PC1. Try to pin the PC2. Pin 200. Oh, sorry. I forgot to modify the security policy. Security policy. PC1 to PC2. It should be 100.1.1.1. Yeah. And destination 200.1.1.1. Okay. Okay. And what about firewall 2? Already synchronized. See that? Source and destination IP address is correct. Then let's test. PC1. Try to ping the PC2. 1.1.1.1. Yeah, good. Good. But the load balance mode do have a problem, because maybe when PC1 try to access the PC2, the traffic go the left side, and maybe the reply packet will go the right side. But it is random. We can check it out. I catch the packet on router 2, interface G000 and interface G001. Oh, close the previous two. And catch the 001. Okay, and the ping again. Yeah, and check the Wireshark. Oh, this time we're lucky. The traffic just go the left side, because the request and reply packet can only be seen at the first Wireshark window, which is the interface of router 2 000, which means the traffic go the left side, not right side. But it is random. If we have another pair of PC, maybe PC4 or PC3, then we'll go the right side. All right. Okay. Hello, are you still there? Just 5 of you. What about the others? Are you still there? Yeah, you're here. Any questions? Am I clear about this part? I'm showing you another scenario of the hot standby system by using the OSPF. Okay, good. And the last mode, now I'm showing you the load balance. It is load balance by default, right? What about active and standby? Now when we check the route information, on router 2 and router 1, the 200.1.1.0 and 100.1.1.0, we have two route information, right? Because it is load balance. So we have two equal cost route. I can choose the first one or second one. Random, totally random. But what if I change the mode? Now the firewall 1, I'll change the dual system hot standby as the active and standby. If we choose active and standby, let's see what will happen. Okay. Firewall 1. Firewall 1, active and standby. And I will set the firewall 1 as the active device. Okay. And firewall 2 as the standby device. Okay. And then let's check the route information on router 2 and router 1 again. Now router 2. Before I change the mode, to go 101.1.0, have two options, right? Now display IP routing table. Okay, see that? This time only have one option. And the next hop is 20.1.1.1, which is firewall 1, interface G100. And what about the router 1? To go 200.1.1.0 before I change the mode. Two options, right? Two options. Display. Okay, let me ask you one question. Yeah, two options. And 10.1.1.1, and this is firewall 1, right? And 30.1.1.1, this is firewall 2. What about now? The next hop should be this one or this one. A or B. A is 10.1.1.1. B is 30.1.1.1. Give me your answer. A or B. You choose A or B. Yeah, you're correct. Yes, A. Let's check. Display IP routing table. See? Oh, sorry. Here. The answer is A. Yes. The next hop is 10.1.1.1 because it is on firewall 1. So the traffic go the left side, will not go the right side. But what if I shut down one of the interface on router 1? What will happen? For example, I will shut down interface of 000. Interface G000. Shut down. in order to simulate the network failure. And then we go back to the router 2 to check the root information to see what will happen. Okay, before the network failure, see, to go 100.1.1.1, the next hop is firewall 1, right? 20.1.1.1. Here, right? And what about now? See? Now the next hop is 40.1.1.1. Is 40.1.1.1. But the cost of value is 65502. Why? Because by default, firewall 2 is the standby device, but the firewall 1 is down. So the firewall 2 becomes the new active device. And the traffic forward go this way. Go this way. 40 is firewall 2. See that? Firewall 2, 40. And we can also check the router too. Display IP routing table to see the next hop of the 200.1.1.0. Yeah, 30.1.1.1, right? 30.1.1.1. And that's firewall 2. Okay, ping again. Test. Yeah, it still runs well. It still runs well. Okay, and if we now the accident recover, the network failure recover, interface G000, undo shutdown, undo shutdown. On router 2, check again. Oh, wait, it needed time to wait. You see, now it's still firewall 2, right? But I said there is one function called proactive preemption, right? And by default, I enable that, which means after one minute, 60 seconds, after 60 seconds, 1 minute, the firewall 1 will become the new active device. Wait. Okay, now, see that? To go 100.1.1.0, the next hop, go back to firewall 1, right? Okay. And this is the scenario, two big scenarios of the HA technology, dual system host and buy. The downlink and uplink, the first scenario is downlink and uplink. We use the switch, which is the layer 2 device, right? And the scenario 2, we use the router as the uplink and downlink device. For the scenario 1 and 2, the firewall can use the corresponding mode to achieve host and buy. In the first scenario, switch, downlink, uplink switch, we use VRP. And scenario 2, OSPF. We use the root cost to control the traffic. Go left side or right side. All right. Okay, and if you have question, just let me know. you have no question, today's course is over. All right. And tomorrow, I'm about to introduce you the AAA. Let me show you. Tomorrow is the firewall user management technologies and the PKI, and the encryption and decryption. I'm gonna introduce you. All right. Because I need to left some time to introduce you the IPsec VPN. And that's a very interesting part. All right. Okay, so today's over. Today's over. See you tomorrow. All right.
Thank you. See you tomorrow.
Yeah. Yeah. Thank you. Thank you for listening. Goodbye. Actually, I'm Gavin, not Kevin.
Bye bye.
Yes. Bye bye. Yeah.